7, sequences, arithmetic versus geometric sequences. And I apologize for the Smart Notebook little water stain here, but my subscription ran out, so that's the reason for that. Not a huge deal though. Okay, let's jump right into sequences. Let's see. A sequence. Well, what is a sequence? So, a sequence is defined as a set of numbers written in a given order. Right? A sequence is a set of numbers written in a given order. So number 1, complete the table below and answer the following questions. A, what type of function is this and why? Well, in order to figure that out, we're going to have to finish off this table here. So, in this first column, going from 0 to 1 to 2 to 3, well, that's simple, to 4 to 5. Now, what's going on? This is basically like our x. This is like our y, looking at our table of values in a calculator. So on the y values, it looks like I'm going up from 0 to 5 to 10 to 15. What is that pattern? Well, I'm adding 5 each time, right? So from 5 to 10 to 15, this is going to be 20. This is going to be 25. So on and so forth. So what type of function is this and why? Well, hopefully we remember this is a linear function. Why is that? Well, it has a constant rate of change. Constant ROC. Right? I'm not multiplying. I'm not going up by 2 and then 4 and then 6. I'm adding 5 each time. So, if we have a linear function, that pattern can also be seen as a arithmetic. This is what this is called. And this is a very important math term that we're going to start using. Arithmetic sequence. It's called that because it has a common difference. Remember this word from last unit with exponential functions. A common difference. And that common difference was actually 5. How much are we going up by? We're going up by 5 here. I'm just going to add this little tidbit here. The pattern here is adding. Okay. So really, anytime I'm adding or I am, if it's a linear function, right? Anytime it's a linear function or I'm adding, that's going to be an arithmetic sequence. So maybe a good way to recognize that is arithmetic starts with an A, adding starts with an A. It's a good way to kind of remember it, if that helps you out. Okay, now, what is the rate of change? Well, it's just 5. Write the equation of the function. Okay, well, the equation of this function is just going to be, what is the equation of this function? We are going to have f of x. Remember what f of x means? That just means y equals 5x. Okay. So anytime I plug in 0 for x, and I'm going to multiply it by 5, right? Any x value in this table, I multiply it by 5 whenever I substitute it in. So if I substitute in 4, I would get 20. If I substitute in 5, 5 times 5, I would get 25, right? Now, Find f of 25. Remember how we do this. If it's asking me to find f of 25, it's really just saying substitute whatever this number is for my x value. Right? I'm replacing 25 with x. So it's going to be 5 times 25. If I get that, I will get 125. Now recall what this means. I have this value of x, right, 25, that's being substituted in for x. But then I get an output of 125. So here's my input, here's my output. I know we haven't discussed it as much, but don't forget this is actually a point on the line. This point is actually 25, comma, 125. This is a point on the line. This is my x, my y. I substituted in 25 for x. I got out 125 for y. So this would be a point on the line. Okay. Number 2. Complete the table below and answering the following questions. Okay, let's complete the table then. Okay. Why won't that go away? There we go. So again, it's giving us from 0 to 1 to 2 to 3. This is easy. 4, 5. But now what's the pattern going on here? I go from 2 to 8 to 32 to 128. Okay, well, it's definitely not a constant rate of change. This has to be an exponential function. If you see here, 2 times 4 would give me 8. 8 times 4 would give me 32. 32 times 4 would give me 128. So on and so forth. So what's 128 times 4? Well, that's going to be 512. And 512 times 4 is 2048. So what type of function is this? This is an exponential function. Why is it exponential? It's multiplying. The pattern is multiplying. Right? And that's the word that we always associate with exponential functions. So this pattern can also be called a geometric sequence. Okay? So anytime it's multiplying, we're going to have a geometric sequence. Just like up here, when we were adding, it's an arithmetic sequence. Well, if it's multiplying, it's going to be a geometric sequence. So exponential goes with geometric, and linear goes with arithmetic. Okay? And it is a geometric sequence because it has, hopefully you guys remember what this one is, not a common difference, but it has a common ratio. And that is just defined as what number am I multiplying by. In this case, our common ratio was 4. Multiplying each number by 4. Write the equation of the function. Well, recall exponential functions always follow this form. Y equals AB to the x. Right? Where A is your initial value, where A is your start or initial, and B is your rate. Okay. So, if we have this function f of x, which is just y, well, what's my A? What's my starting value? Well, when we're starting at 0, my number is 2. So my A is going to be 2. My B is my rate, or my common ratio, right? So it's going to be 4 to the x. Here's my function, the equation of my function. 2 times 4 to the x. And then part C, find f of 8. Again, I'm just substituting in here for x. So if I want to find f of 8, it's saying to substitute in 8 for x. So it would be 2 times 4 to the 8th. And what is that? Well, if you just put that in your calculator exactly as you see it, you would get the answer of 131,072. Okay? So we have arithmetic sequences and we have geometric sequences. Arithmetic are with linear functions, and geometric are with exponential functions. Okay. Now, turn the page over. We'll do a fill in this box, get a few examples down, and then we will end this video. So, arithmetic sequence. An arithmetic sequence is a specific order, each having a common difference. Right? Arithmetic has a common difference. And again, it represents a linear function. Arithmetic sequences represent linear functions. Now, geometric sequence, a set of numbers in a specific order, each having a common ratio. And it represents an exponential function. Okay. Let's take a look at some examples. 1 through 4. Let's use red for this. Okay. Given the sequences below, it wants us to do 3 things. Part A, determine if they are geometric, arithmetic, or neither. Part B, identify either the common difference or the common ratio to justify part A. And then C, identify the type of function for each sequence. Okay, simple. Part A, or number 1. It's giving us a list of numbers, 5 to 10 to 15 to 20 to 25. Well, hopefully we can see right off the bat this is going to be a linear function because it has a common rate of change. But let's answer A, B, and C as it wants us to. So, part A, determine if it's geometric or arithmetic. Well, since it's going up by 5 each time, hopefully we can see that this is going to be arithmetic. Right? This is going to be an arithmetic sequence because it's following a linear function. Part B, identify the common difference or common ratio. Well, again, it's going to be common difference because it's an arithmetic, a linear function. The common difference is 5. Then part C, identify the type of function. Well, it's a linear function. It would be a linear function, right? Number 2, I'm going from 64 to 32 to 16 to 8 to 4. Okay, well, hopefully we see that's not a linear function, but that's definitely exponential. And what is it? Like, what am I going down by? How do I figure that out? Just look at it. How much am I going down by? I'm going down by half, right? I'm multiplying by 1/2 each time to get down, or dividing by 2. So, part A, that's a geometric sequence. Part B, hopefully we see it's a common ratio, and that ratio is 1/2. And part C, is it linear or exponential? That's exponential. Okay, I want you guys to do 3 and 4 by yourselves. I will write down the answers. Let's lower this. So for number 3, part A, it is a geometric sequence. If you don't want the answers yet, if you want to think about it, pause the video now, and you can try it yourself. Part B, that's a common ratio of 3. And part C, since it's a geometric sequence with a common ratio, that's an exponential function. And number 4. Part A, let's see, what kind of function do we have here? It's going from 1 to 4 to 9 to 16. Okay, this one's a little bit different. This is not the same as what we were just working with. Why is that? We'll take a look. If I go from 1 to 4, I'm adding 3. From 4 to 9, I'm adding 5. From 9 to 16, I'm adding 7. From 16 to 25, I'm adding 9. This is no constant rate of change, and I'm not multiplying by the same number either. This is neither. This is not either sequence. This isn't arithmetic. This is not geometric. Okay? And this is going to end the first video. We'll finish this in the next video. Okay, guys?